Okay, welcome and thank you for coming today. My name's Andrew Cook. I'll be your trainer today. We've just got a short session for you today, which is going to be carry out measurements and calculations. We've got our course code up there as well. Before we start, we'll just do a little bit of housekeeping. You've come in today via the front door. If we do need to evacuate, if you do hear the fire alarm go off or the evacuation signals come out, we'll basically move out that front door in an orderly fashion, meet out on the front of the property there, and we'll just do a roll call just to make sure everyone's accounted for. If you do need toilets facilities, if you just head out through this door here and down to the left, you'll see both male and female toilets there as well. We have a little kitchenette in the back there as well, so feel free to make yourself a cup of tea or grab a snack there if you like there as well. Was there any questions about that housekeeping at all? No? So I've introduced myself. I'm Andrew the trainer. I've been taking this course for a while now. I understand your employer has asked you to come do some training. Just wondering if you might be able to give us a quick introduction of who you are and why you're here, and yeah. Okay,
I'm Mary and I've just been promoted to team leader just very recently, and so I wanted to come and do the training that they suggested, just because there are times I have a bit of trouble with my reading and writing and things if they're not quite the right fonts and things like that, and I really wanted to make sure if I'm called on now as a team leader, I have a better idea of an understanding of what I need to do.
Sure, no, that's great to know. And I did get that information earlier on as well. So as a result, I've given you a glossary of terms there as well, but give it to you with a larger font there to make it easier to read. And we've also just got a handout there which will help following along as we go through the slides. So we've got bigger pictures, bigger font there for you as well. Just before we continue on, are you happy to be recorded for this training?
Yes,
that's okay, sure. Okay, well, thanks for coming along and thanks for letting me know that. So hopefully we'll be able to give you some information and help you in your position as well there as well. So like I said, our course code is carry out measurements and calculations. So for this part here, we're going to go through some of the learning objective there as well. So we're going to be able to identify types of basic measurements and their uses. We're going to measure and calculate accurately, and we're going to confirm and record measurements. So what we're going to do firstly is we're going to go through what's called linear measurements. So a linear measurement is a measurement between the distance between 2 points. So a linear measurement could be the length of a house, it could be the height of a house, it could be the width of a house, for example. So the most common linear measurements include length, width, depth and height. So when we're talking about length, this bit of paper for example, the length is usually the longest part of the thing we're measuring. So in this instance would be the bottom section of the page there as well. The width is the other measurement along the other side of that as well. So as you see, when we go further along, when we're doing calculations like perimeter, we'll use measurements like length and width. When we're talking about depth and height, this is more referring to a three-dimensional object. So it's referring to a third measurement, which we'll be able to use to calculate volume of a particular item as well. Any questions about that at all? All pretty straightforward? Yeah, sure. So like I said, length, L for long length, width is for the side of it there as well.
Oh, well, one question. If, for instance, you had a picture on the wall, but it was more a portrait style picture, like this page, if someone asked you for the length, would you give them the bottom or would you give them the
I'd still height? Probably do the top there. So what you're saying there is, if we're looking at more portrait there now, is that correct? Yeah, so I'd say the length would still be the longest part of the side there as well, whereas the width would be the bottom part there as well. Look, it doesn't matter if you've got the two mixed up as well, as long as we can distinguish between the length and the width, as you'll see with our formulas coming up.
Okay, so label what one you've done the length and stuff.
You could do, yeah, that's the best thing to do.
Yeah, okay.
Absolutely. Okay, and so now that we've talked about our lengths and widths and depth and height, we can go on to some of our areas where we can do calculations. So the first thing we're going to talk about is perimeter. So as you see on the picture here on your guide there as well. Well, first we've got a picture here. It gives you an example of length, width and depth. So this is a trench, for example, for some footings. So if we need to know the actual volume of that trench, we would need to use all three measurements. So our length, our width and our depth, which gives us our three measurements. However, if we were just looking for the perimeter of that trench, we would just simply use our length and our width. However, on this next picture down here as well, we've got the perimeter of a field, for example. So this is where we can use our length and our width to measure the perimeter. So a perimeter is the boundary or the outside edge. In the building industry, it's used to refer to things like fencing. So like a perimeter fence around your property or around a business, for example. It can be used to measure gutters. So if we need to measure the perimeter of a house to install gutters, we need to know what that length is all the way around the house there as well. And for example, external wall lengths as well. So again, if we're looking to supply a certain amount of material, we work out the perimeter of that as well. Righto. Now we have the area. So the area is the amount of space inside a boundary or outside edge. Square units are used for area measurements such as meters squared or square meters. So examples in the construction industry include the floor area of the building. So you had a staff member of yours come in and then we talked about plans. So for example, on this floor plan as well, it can give us a square meterage of the or an area of this particular plan. But we can talk about wall and ceiling areas. So can you give an example of who might need to use a wall or ceiling area?
Roofers, painters, insulation, gyprockers.
Yeah, absolutely. So they'd need to know the area of the wall, for example, to be able to calculate the amount of materials they're going to need for that particular job. So a gyprocker, like you said, might come in and need to measure up all their walls to be able to order the different size sheets and to know the area of those particular walls. Same thing with a painter. He might have a rate of painting per square meter. So as a result, he'll need to work out the area to be able to charge accordingly or to be able to give a quote to a customer as well. We also have floor area of individual rooms. So for example, a tiler might need to use the floor area because he's obviously working on the floor and needs to work out materials for that as well. And like you said, roof area for roofers or an area of a building block. So if someone's selling a block of land and they need to know the size of that, it will be referred to as square meters. Once you start to go to larger blocks of area, you're talking in acres and hectares. So they will start to go into much larger sizes than that as well. So if we're calculating the area, we just need the same measurements we have for the perimeter and the area, but we'll go into that a little bit later when we look at calculating those figures. Okay, now we're going to talk about circumference, radius and diameter. So can you suggest where we may use circumference, radius and diameter? What particular objects we calculated on?
Pipes. Lights.
Yeah, sure.
They're round.
So as you see, with a circle, we calculate circumference, radius and diameter. So this is again, the perimeter of the circle is called the circumference. So that is the outside edge of the circle. So for example, if we had something circular, this pipe for example, and we want to measure around the outside, that would be called the circumference of the circle. When we're talking about the radius is the distance from the center of a circle to any point on the circumference, called the radius. So if we measured halfway in the end of this and out to the circumference, that would be what our radius is called. And then we have our diameter. So that diameter is the distance across the circle through the center, and it's called the diameter. So if we measure from outside edge to outside edge through the center, that would give us the diameter. So they're all relative to each other. So as a rule of thumb, the radius is always half of the diameter. So do you think we may be able to use these figures in calculating things like area and that in regards to a circle or a cylinder, for example?
Well, sounds like it's similar, but it's just a circle rather than a piece of paper. So
Sure, yeah.
it makes it a bit trickier, but you could do the area of those.
Absolutely. So now we talk about volume. So volume is of an object is the amount of space it takes up in 3 dimensions. So to measure the volume, we use 3-dimensional units or cubic meters, such as millimeters squared or meters squared. So like I said before, we're going to use 3 measurements now. So usually the length, the width and the height to give us a 3-dimensional or a volume of a particular object. So calculations of volume in construction industry are used to determine things like how much soil we need to dig out of the ground or excavate, how much tile adhesive we need. So for example, on the bag of tile adhesive, they will give us how much area or volume that particular tile adhesive will cover. So for example, it might say this 20-litre bag will cover approximately 8 square metres of tile. So as a result, the tiler will be able to then calculate how much they'll actually need for the job. Usually they'll allow for a bit of spoilage or a bit of extra. Reason being is that you don't want to work out exactly how much you need because often there is some wastage or spoilage, and as a result you might have to then go out and purchase more, or you might end up short on material there as well. For example, a bricklayer may use sand in their mortar as well. Tins and or buckets of paint, so going back to our painters, paint will have a certain amount of square meterage it will cover with a particular volume, so a 2-litre tin might cover 10 square metres of wall, for example. Tubes of fixative required for the job, so silicon, things like that, or concrete required to pour a slab. So concrete's always talked about in cubic metres. So again, working out the width of the slab, the length of the slab multiplied by the depth will give us a cubic meterage of concrete for that one as well. Alright, for solid objects, volume is measured in cubic meters, in cubic units such as cubic meters. The little 3 that follows the m in meters represents the 3-dimensional solid object, namely the length, width and height. So I have an example here of a 3-dimensional object. So we have our chip box here. So like you said, we can measure our length, our width and our depth. So it's our 3 measurements there, and it gives us the 3-dimensional unit. So as a result, we'll be able to measure volume of this particular unit. Can you give us an example? If we were to measure just the perimeter of this box, where would we actually measure that from, or what dimensions would we take from that?
Just the length and the width.
Yep, that's correct, because we're just measuring the outside of something. The perimeter, we're not actually measuring the volume of it as well. So we could use the same dimensions to measure area as well, because we use our length and our width for our area. It's just measuring the area of this surface here. Whereas when we're doing volume, we're talking about the whole lot. So if we were to try and fill up this whole section here, we'd need all 3 measurements to be able to measure that as well. So yeah, any questions about that at all? That's all pretty straightforward.
No, that's fine.
Yep. And how are you following on with that handout now? Is that text okay
not
to you?
too bad. It's pretty good. But do you know if there's an app I can use as a screen reader or something? So when I get home, if I can get it read to me?
Yeah, sure. So yeah, there's plenty of AI apps out there that you could use. I can get a list of them for you as well, but what they'll do is they'll read it off the page and then they can dictate to you or give it to you as other form as well, or can actually read it out to you. So yeah, there's definitely plenty of different options out there for that sort of thing as well.
And just me struggling sometimes with my words, I'm a bit better with numbers, but could I use spell check in the workplace, do you think? Or do you think that would be frowned upon? Or?
No, absolutely. Spell check's there to be used. And yeah, it's definitely a handy tool to use as well. So it'll make you come across as more professional as well in your position. So nothing worse than having a form submitted and got spelling mistakes and things like that as well. So look, there's definitely lots of products out there that can help you, and spell check being the most simplest of them there as well. So
I will be sending more emails now that I'm the team leader.
Yeah, absolutely. Yeah. So look, I recommend using whatever you can to help you along there as well. So again, we may measure volumes in liquids or in mass. So we might talk about a particular cylinder or a can. We may need to measure the volume of the liquid. So it's usually measured in litres or millilitres. So you'll see a standard can of Coke might be 375 millilitres. Our as conversion might be 0.375 litres. Whereas other things like tins of paint and that, for example, will be measured in litres as well. So it would take 1,000 litres of water to fill a 1 cubic metre container. So a 1 cubic metre is basically 1 metre by 1 metre by 1 metre. Gives us 1 cubic metres. So mass. Mass is what we often call weight, or how heavy something is. So for example, our box will have a certain mass, and as you can see on here, it's written down as 392 grams. So mass will be either measured in grams or kilograms, but when you go up to larger weights, it could be up into tonnes and that as well. So a tonne is 1,000 kilos. So again, this is the metric system, so some people may use the imperial system, which is ounces and pounds, but in Australia we more commonly use the metric system there as well. Different objects or substances have different masses even if they have the same volume. So what that means is, for example, this glass jar is heavier but smaller than this box. So what that's saying is that something can be heavier but physically smaller. So it would have a different mass related to that in regards to volume. So for example, a pillow may be bigger in volume but less in mass because it's made of feathers and lighter. So we've got the old saying, what weighs more, a ton of lead or a ton of pillows or a ton of feathers? And they both weigh exactly the same, but mass wise, the feathers are a lot lighter in regards to their size. Okay, so measuring accurately. We need to measure accurately. It's important because incorrect measuring can result in wasted time or push you behind schedule, waste of material costing you or the business money, or ruined aesthetics such as incorrectly sized tiles. So we always use the saying, measure twice, cut once. Have you ever heard that at all?
Yeah, I think I have, but I'm not sure what it means.
So a good way to explain that would be cutting a piece of timber. So for example, we obtain a measurement by using a measuring tape, for example. We write that measurement down, but it's always good practice to measure that a second time, because what can happen there, we may inadvertently take 100 millimeters off it, for example, and cut it too short. As a result, we haven't been able to use that bit of timber, so it might either be wasted. We may be able to use that later on, but as a result, we've wasted that bit of timber. So the saying, measuring twice, cutting once, is measure it again, and then cut it once, so that you don't have to cut it again. So whereas if you measured it once, cut it twice, then it makes it a bit inefficient there and may cost your employer a bit of money there or something like that. So, yep. So again, if we measure incorrectly, we could waste material or cost the business money. So we may not measure enough sand we need for the tiler. So as a result, he may need to then have to go out and buy more sand, which can take time and obviously cost the company or the business money by unproductiveness there as well. So rounding off. So rounding off is reducing the number of digits in a measurement or calculation to the nearest decimal point or whole number. Must be of time, rounding off to 2 or 3 decimal places will be accurate enough. So again, we may have a large measurement, but to make it easier to use, we may round it up or down. So for example, we remember in school that if we had a number between 1 and 10, say if it was above 5 and then around 8 or 9, we would then round up to 10. Where if it was 6 or 7, we would round down to 5. So it's just a way of simplifying a measurement there as well. In the construction industry, we may round up, for example. So if we're measuring how much soil we need for a garden, if we get to 1.8 cubic meters, we may say round up to 2 meters, for example, just to give us a bit of extra there as well. In that situation, it would be better to round up than round down, because if we rounded down, then we would end up being short of material there. And that rounding up just gives a little bit of additional material there as well. All right. So was there any questions just in that first little part of the session there at all in regards to talking about perimeters, areas, volumes, things like that?
No, that's fine, thank you.
Pretty straightforward.
Yeah.
Okay, so what we're going to do next is we're going to look at how we calculate a perimeter. We're going to look at calculating the area of a rectangle, a triangle and compound shapes. We're going to calculate the volume of a prism and a cylinder and calculate mass. So as we'll go through, we'll have a couple of examples and we'll be able to get a bit hands-on there and do a few calculations as we go there as well. So I've given you a calculator there and also a ruler and a measuring tape there as well. Okay, so as we mentioned, a rectangle is any four-sided figure where angles are 90 degrees. So we're going to look at calculating the perimeter of a rectangle. So do you remember the formula for calculating perimeter at all?
The perimeter is the length times width plus width times 2.
Correct, yeah. So I apologise, we didn't actually run through the formula, but we talked about what figures we needed. So we needed our length and our width. But if you imagine that rectangle has 4 sides, so to work out the outside part of that or the perimeter, we can either add those 4 together or we can add the length and the width together and multiply it by 2. So what we're going to do, you've been given a piece of paper there, so we might go through them. We're going to measure the length and the width of that and write it down. So can you tell me, you've got your ruler there, what's the actual length? We'll talk about in centimetres, so what's the length of that page in centimetres?
In centimetres, it would round up to 30 centimetres.
30 centimetres, perfect. And also the width of that?
Would 21.
21, okay, perfect. So what we can do is we can add our length and width together and times it by 2 would probably be the most easy there. So our length was what, 30 centimetres, correct?
Yep.
And our width was 21.
Correct.
So what's that give us together?
51.
51. You can use your calculator there if you need to, if you're struggling with that at all. So 51, and then we times that by 2.
102.
102 centimetres. So that is our perimeter of our page there in centimetres. So for example, if this was a block, we might have been 30 metres and 21 metres. So that would give us 102 metres around that perimeter as well. So if we wanted to get a quote for some fencing, we could ring the fencer up and say, our perimeter of our block is 102 metres. Can you please give us a price based on that? So that's pretty straightforward, would you agree?
Yes.
Yep, not too hard.
Oh, good.
Okay, so now we're talking about circumference of a circle. So whenever a circle is drawn, no matter the size, it's always the case that the circumference is approximately 3.1416 times the diameter. We refer this figure to pi, which also shows the Greek letter there as well. So this is quite a common figure we use. I think the actual full amount of pi is equal to roughly about 20, goes about 20 decimal places. But we do simplify it. There is also on your calculator as well, there is actually a pi symbol there which we can use to calculate for it there as well.
Just a bit small.
Little
You
bit
might need
small.
to point that one out to me.
Yeah, sure. So I can find that one for you there as well. So as you can see, that's the pi symbol there. You can see that one there. I agree, it's a little bit small there, but yeah, by using a screen root or something to be able to highlight that for you there as well.
Yeah.
But as a rule of thumb, we can use 3.1416 to be able to simplify that and make it a little bit easier as well. So for example, like we said, the circumference of the circle is pi times d. So do you remember what the d part of that is at all?
The diameter.
The diameter,
so
correct.
The whole
So again,
across the circle.
sure. So again, if we look at this particular piece there, may I borrow your ruler? Is that okay? Thank you.
Certainly.
So if we're looking at a 1-to-1 scale, which is there, for example, so if we measure our diameter there, we're roughly, let's say, 6.4 centimetres, and then we multiply that by 3.14, it's giving us roughly around about 18 centimetres there. So that's talking about the outside area of our circle there as well, all the circumference. So does that make sense there?
Yeah, so that's just the circumference, that's not the area of the
Not the area, no.
cylinder.
We're just talking
Okay.
about the distance around the outside of that circle there as well.
Yeah.
So we used our diameter times by our pi, which is 3.1416.
Yeah.
So, yeah.
Okay.
Okay, and now if we're looking at our page there as well, area of our rectangle. So for example, we can use our page again as the area. So again, our formula for our area is our length times by our width. So before with our perimeter, we did our length plus our width, multiplied by 2, but this is actually multiplying our length by our width. So we don't need to use the all 4 measurements there because we're only multiplying our length by our width. So again, we can do this pretty straightforward with the measurements we had. So we had a 30 centimetre length multiplied by 21 centimetres. So you might need your calculator for that one. But do you reckon you can do that one for us there as well?
Oh, of course. 630.
630 square centimetres will be the area of that as well. So again, we might be looking at an area of a block. So we might have 30 metres multiplied by 21 metres, which would give us 630 square centimetres as well. Square metres, sorry. Thank you for that. And that will have our little 2 next to the metres figure there as well. So that means square metres, which is our area. Now, do you remember what figure we put next to that when we were talking about volume at all?
Milliliters?
Oh, so if we're talking, volume or something, but we'd have a little 3 next to the figure there as well.
A little 3.
That's correct, yeah.
Of course.
Okay, so now we'll look at our area of our circle. So our area of our circle is pi r squared. So our pi being our 3.1416 multiplied by the r. Do you have any clue of what the r could be?
Half the diameter.
Half the diameter, which is also known as what?
A radius.
The radius, yeah, perfect. So we have pi r squared, so we'll be 3.14 multiplied by our radius and squared. So that will give us our area of our circle there as well.
Okay.
So if we're looking at the area of our triangle as well, so again we have a few dimensions we have here. We have our base and our height. So a triangle will always have a height, which is the highest part to the tip of the triangle there as well. So our formula for area of a triangle is half of the base times by the height, or you might hear perpendicular height. So again, we only need to know those 2 figures to be able to give us the area of our triangles there. So it says the base of a triangle may be on any of the 3 sides, but the height must be relative to the base at 90 degrees. So we can see there, if we measured our distance between our height there and our base, it would need to be at 90 degrees there. Whereas if we used one of these sides, the height would not be relative to 90 degrees. So we have to use that as well. Okay, area of compound shapes. So to calculate the area of more complex shapes, you need to divide them into shapes which area can be calculated more easily. So as you can see here, we have a L-shaped compound shape, but to make it a lot easier, we could convert it into a square by drawing a line across there and making it a rectangle as well. So again, with a square, because we have equal sides, we could just multiply the 2 sides together, and same with our rectangular, the length by the width there as well would give us the area, and then we can then add them together to give the area of compound shapes. So if we have a floor area or a room in a house which may have a different shape, we'd be able to just split it up into different areas to be able to calculate the area there as well. Okay, volume of a prism. So if we go back to our box here, this is what's called a prism. So again, we have our length, our width, and our height or depth. So by using these 3 figures here as well, so I might borrow that tape measure off you if I could, and we'll do a quick calculation here. So I might measure this off for you, and if you could do it in the calculator there. We're going to do this one in millimetres. So we have 290 millimetres. We're going to multiply that by the width, which is 240 millimetres. And then our depth or height will be 130 millimetres. Okay, so what do we get there? Quite a big number, isn't it?
Yes.
Yep, which is
904, no, sorry, 9,440,000 48,000
Yep. So what we could actually do
millimetres.
to actually bring that back to meters as well, we could actually divide that by 1,000 as well, which would bring it down to meters. Because it's such a high figure there as well, we could actually divide it by 1,000 and give us our meters there as well.
Mm-hmm.
So that would be our volume of our prison there, multiplying the length by width by height. So for example, if this was 1 metre by 1 metre by 1 metre,
Mm-hmm.
it would give us 1 cubic metre. So our volume is always going to be in cubic metres or cubic centimetres or cubic millimetres there as well. Okay, so we have volume of a cylinder as well. So again, we're using our pi figure there, pi r squared multiplied by our height there as well. So this is if we were measuring a cylinder with a solid shape. So for example, a can or something like that as well. So it's got two identical ends that are the same size and shape. So it can't be different at the top as opposed to the bottom there as well. And then if we talk about a mass, so you may be required to calculate the mass of an object for the purpose of organising lifting equipment. So our volume, which is the mass of materials per cubic metre, or multiplying the length times width times height. Okay, so that's the end of our session there as well. So have you got any questions about what we learnt there in the session at all?
No, but would you be able to maybe send me some different shapes that I could practice working on?
Yeah, absolutely. Or as a suggestion in your workplace, you may be able to identify different materials there, boxes and things like that you might be able to practice on as well. Even in your kitchen or something like that, you may have some cans or bottles, something like that, which you can then measure up and use these formulas. So in the handout there as well, I've given you a formula sheet there, which has some easy reference there as well, so that you can then refer back to that if you need to work out how to do it as well. So, yeah, any other questions at all?
No, that's about it.
All good?
Yeah,
Okay.
thank you.
All right, well, thank you for coming in today and participating in the training. Hopefully it was informative and, yeah, have a good day. Thanks very much.
Thank you.